This video is measures of position part 1. I'm positive we're going to have multiple parts to this video since we have so many items to cover: percentiles, quartiles, 5-number summary, and box plots. So let's get started. Suppose you score a 155 on the LSAT. That's the law school admission test. You'd like to know how well you did relative to everyone else who took the test. So if we look at the score of 155, that might not tell you a whole lot on how well you did. We're used to seeing scores between 0 and 100%. This is a score of 155. I'm not sure out of how much. So if you knew you scored 63% better than others who took the test, that would be a better indication of your success. So comparing your score to other scores. So we often want to know where a particular data point falls in the data set. That would be, you could kind of line up all the LSAT scores of everyone that took the test and see where does your 155 fall compared to everything else. So that's called a measure of position. It tells you the position where your data point falls. So there's two types that we're going to cover in this section. The first one is called percentiles, and the second is called quartiles. All right, let's start with percentiles. Quartiles are actually a type of percentile. So we're going to start with percentiles. So this is the definition of a percentile. The pth percentile. Now, you're not going to say pth percentile. There will be a number there, like they might say, let's just put the pin on, the 20th percentile. Okay, so the pth percentile separates the lowest p% of the data from the highest 100 minus p%. Now that might seem like it's a little bit difficult to understand, but let's replace this with some numbers. Instead of p%, for the pth percentile, let's use 20th percentile. So this would mean that it's the number that separates the lower 20% from the highest. If you've got 20%, what's left over? So the entire thing is 100%. That's why we do 100 minus 20. 100 minus p would give us 80%. So if you look here, this is showing the data lined up as in histogram form. And so this number, whatever this number right here is, that number right there is going to separate the lower p% from the upper 100 minus p%. So if it was the 20th percentile, it would separate the lower 20% from the upper 80%. If it was the 30th percentile, it would separate the lower 30 from the upper 70. If it was the 40th percentile, it would separate the lower 40 from the upper 60, so on and so forth. All right, now how do we find percentiles? Now it starts with a basic formula, but there is a process to it that you need to learn, and it varies depending on the type of answer you get. So first off, it's important to note that the formula that I'm going to give you for a percentile does not actually find the percentile. It is called a location formula. So it's not used to find the percentile, it's used to find the location of the percentile. It's kind of like finding a point on the map, so kind of showing you where it is. So it finds the location, not the actual percentile. So this is the formula that you need. L equals P over 100 times N, where P is the percentile. So if you're finding the 20th percentile, that would be 20. And N is the number of numbers. L, again, represents the location of the percentile. Okay, so it's important when we see formulas to know what each variable in the formula represents. So there we go. So now, like I said, this is a process. So we always start with the formula. Actually, before I would even start with the formula, I would do this step. This is so important for anything to do with percentiles. You want to make sure your data is in order from smallest to largest. You can do this by hand. You can also do this with the calculator. You can choose You can choose, you can put your data into one of the lists, such as L1, and then you can choose Stat, and then choose Sort A, that stands for Sort Ascending, and then specify which list you want it to sort, and then, such as List 1, and then once you do that, when you go back into your list, you'll see that it's sorted from smallest to largest. Anyway, so make sure you put your data in order first. Next, you're going to use the formula. You're going to plug in your P and your N into the formula and find your L. Now this is where, I told you it was a process, so this is where these extra steps start. Now once you find your L, it's either going to be a whole number or it's not going to be a whole number. So a whole number are numbers like your counting numbers, 0, 1, 2, 3, 4. Not a whole number would be a number that has a fraction or a decimal along with it, such as 2.57. Okay, so what do we do if L is not a whole number? We're going to round up to the next whole number. That is where you need to throw out the rounding rules you have learned in the past, where if you've got 5 or above, you go up. If it's 0 to 4, you stay the same. For this particular type of problem, if L is not a whole number, you're going to round it up to the next whole number. So in other words, if I have 5.2 and I wanted to round that to a whole number, normally I'd round that to 5 because the 2 tells the 5 to stay a 5. But if this were L, the rule says round it up to the next whole number. So the next whole number would be 6. So be careful there. Now once you find it, because ultimately L needs to be a whole number in the end. So we make L a whole number, it's 6. This is the location of where our percentile is, and this is why it was important to put the data in order. So once you find the percentile is 6, once we round it up to a whole number, we count the numbers in the list that you've put in order and find the 6th number. So the number that's in that L position that was rounded up, that's your actual percentile. Now the process is a little bit different if it is a whole number. If it is a whole number, so let's say we got L equals 8. Okay, now we can't just say the location is 8, so it's the 8th number. That would be too easy. For this one, they want us to take the average of the value in this position and the number right after it. So we're going to average the 8th and the 9th number together. If you got L equals 7, you would average the 7th and the 8th number together. If you got L equals 21, you would average the 21st and the 22nd number together. Again, this is why it's so important to put the numbers in order first. And when we say average, that means find the mean, add the two together, and divide by 2. So let's look at an example. In Miss Guzman's statistics class, the scores on the first test were as follows. 82, 92, I'm not going to read the whole thing. You can read those. Find the 80th percentile of the data. Find the 63rd percentile of the data and the 50th percentile of the data. So let's start for all of these. Let's put the numbers in order. So again, if you type these, if you go to Stat and Edit and put these numbers in L1, and then you're going to go to Stat and choose number 2, Sort A, then you need to specify that where you put the data. I put mine in L1, so you type in L1, second one, and then hit enter, and it's going to say done. Once it does that, it's going to put the numbers in order for you. So I've written them out for us. And it says find the 80th percentile of the data. So L equals P over 100 times N. So that is, P is the 80th percentile, so it's 80 over 100 times the number of numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 20 numbers. So 80 over 100 times 20, and you can just put that in your calculator and find out what you get, and we get 16. Now, This is L. This is your location. This is your location. It is not your percentile. So the answer to part A is not 16. So let's go back real quick and see what happens. If L is a whole number, then we need to average, take the average of the value in that position and the number right after it, directly to its right. Okay, so the 16th number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This is the 16th number. This is the number right after it. So we're going to take the average of those two. We're going to say 92 plus 93, and we're going to divide that by 2. So 92 plus 93 is 185 divided by 2, and we get 92 and a half. So that means that the 80th percentile is 92.5. So if you separate the data and put a boundary at 92.5, it would split the data into the lower 80% and the upper 20%. That's what we would have found when we do that. All right, pause the video and you try the 63rd percentile. Okay, hopefully you had time to pause it and try to work this out. Let's look at what happens. For the 63rd percentile, we plug 63 in for P. There's still 20 data values, so 63 over 100 times 20 is 12.6. For this one, we use the rule for when we get an answer that is a decimal. It's not a whole number, so we're going to bump it up. So we're going to bump 12.6 up to 13. And then we're going to find the number in the 13th position. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now this one's cool because you don't have to do any averaging or anything extra. 88 is our answer. So the 63rd percentile is 88. All right, one more. You guys try to find the 50th percentile. So go ahead and pause the video and see if you can find that. Okay, hopefully you paused the video and found the 50th percentile. Let's go over that. So for the 50th percentile, we put 50 in for your P, so 50 over 100 times the number of numbers, which was 20. And when you multiply that out, you get 10. 10 is a whole number. So we find the number in the 10th position. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 84. And then we take the number after it, 86. So 84 and 86, and we average those together and divide by 2. So we get 85. 85 is the 50th percentile. Okay, so why don't you try this next example? Hit pause again. Now this is in table format, so it might be helpful to you if you list the numbers out first. So the first number is 4. There's 2 of those. Then there's 5 5s, so on and so forth, and go ahead and list those out. But anyway, pause the video and see if you can figure it out. Okay, so here are the answers. Right here, 6.5, 8.57. For the 28th percentile, if you did 28 over 100, and you multiply that times the number of numbers. Now, if you add all these together, all the frequencies, that means there's 50 numbers. And you're going to get 14. So you take the 14th and the 15th number, average those together, 6 and 7, and you get 6.5. For the 80th percentile, you do 80 over 100 times 50. And I believe you get 40, so you're going to average the 40th and the 41st number together and get 8.5. And then for the 40th percentile, oops, got that extra line in there. For the 40th percentile, you get 20, so you average the 20th and the 21st number together and you get 7. Okay, going to stop here, and we're going to pick up with the next video for part 2 on the next slide. If you have questions, let me know.